Now, suppose it is given that let x and y be two independent Poisson random variate that means here we are using, so x has some Poisson distribution with parameter lambda 1 and y has some Poisson distribution with parameter lambda 2, and also x and y are independent, that we are assuming here independent. So, find the probability mass function of z is equal to x plus y. Suppose you are there x is a number of accident in a city, some city 1, and suppose number of accident in some Chennai, and y is the number of accident in Mumbai. So, then if you want to find the combinedly what will be the number of accident in both the cities, both the places, then what will be the probability mass function, what will be the probability. So, then in that case we have to find the probability mass function of z, probability of z small z. So, this is nothing but probability of z equal to small z. Now, what will be range of this random variable? Range of the random variable R z, this will be C. Range of x is the number of accident for Poisson random variable, this is 0, 1, 2 like this, and range of y is nothing but 0, 1, 2 like this. Then range of z will be, so because you are a number of accident it will be add, this is also 0, it can be possible 1 like this, this is also will be range, but we do not know what will be the distribution, how. So, that is why we want to find it, the probability mass function. So, now if you put what is the probability of z is equal to 0, what will be the probability that z is equal to 0. So, this probability is nothing but, see that probability is x also x plus y will be 0, because z is equal to x plus y. Now, when it will be, because minimum values x can take 0. So, then x plus y 0 is only possible that x is equal to 0 and y is equal to 0, and because they are independent random variable, this is it, we can multiply. We know that the definition of a independent definition of the independent events, because it is one events and we are writing this comma another events. So, it will be more clearly discussed when we will discuss bivariate random variable, but you can consider like this is event A, this is event B, and this comma means it is nothing but A intersection B. We are talking about probability of A into probability of B. Probability of A intersection B is nothing but probability of A into probability of B. So, that here we are also using this property. So, this is nothing but x equal to 0 into probability of y is equal to 0. Now, if probability of x is equal to 0 is e to the power of minus lambda 1, probability of y is equal to 0 is e to the power of minus lambda 2. This is nothing but e to the power of minus lambda 1 plus lambda 2. So, this is the probability. Now, if you consider what is probability of z is equal to 1. So, probability of z is equal to 1, it is nothing but probability x is equal to x plus y is equal to 1. Now, what are the possibility that x plus y can be 1? So, that see x and y, what can be the values of x and y? This is 1. Suppose it is 1, then it has to be 0. If it is 0, then this has to be 1, and any other value it is not possible to sum to 1. So, that is why this is nothing but possibility that x equal to 1, possibility that x equal to 0 and also y is equal to 1, plus because these are mutually exclusive event, this is one event, this is another event, that it is equal to 1 total number. So, this is nothing but probably that x is equal to 1 and y is equal to 0. So, then it is independent concept, again we will use x is equal to 0 into probability of y is equal to 1, because they are independent, plus probably that x is equal to 1 into probability of y is equal to 0. So, then how we will find? This is e to the power of minus lambda 1 and this is e to the power of minus lambda 2 into lambda 2, and again plus e to the power of minus lambda 1 into lambda 1 into e to the power of minus lambda 2. So, here you can see that what we are getting finally, this is equal to probability that z is equal to 1 So, this is nothing but e to the power of minus lambda 1 plus lambda 2, this is lambda 1 plus e to the power of minus lambda 1 plus lambda 2 lambda 2. So, here you can see that. So, this is e to the power of minus lambda 1 plus lambda 2 lambda 2, this is minus lambda 1 plus lambda 2 lambda 1. So, that I have written here. So, then if you take common here, e to the power of minus lambda 1 plus lambda 2 into lambda 1 plus lambda 2. So, that is probability of z equal to 1. So, by computing this, we got some kind of pattern that how this probability we can compute. So, basically in general, if we write probability that what will be z equal to some small z, z can be 0, 1, 2, 3 anything, this is nothing but we have to find probability that x plus y is equal to z. Now, this probability how can we can find? So, it can be possibility is x y. So, this z, if x is 0, y has to be z, because total is z. Now, if x is equal to 1, then this value has to be z minus 1. Like this, it can go up to z, and this will go, if it is z, then this is 0. So, we can write this probability is nothing but, so summation of probability that x is equal to r can be 0, 1 to z, and y can be z minus r, and r is equal to 0 to z. So, see that x can be r, comma mean intersection, that both it has to be happen, and y is equal to z minus r. So, then this is considering all this event here. So, x is equal to 0, y is equal to z, x is equal to 1, y is equal to z minus 1, like this, x is equal to z, y is equal to z minus, because r is 0 to z. Now, this can be represented as, so see that summation r is equal to 0 to z, probability x is equal to r, because they are independent random variable, and probability of y is equal to z minus r. Now, if you can we just simplify these things, this is nothing but e to the power of minus lambda 1 lambda 1 to the power r by r factorial. This is e to the power of minus lambda 2 lambda 2 to the power z minus r by z minus r factorial. So, then if you combine, if you write, see that if you simplify these things, it is nothing but e to the power of minus lambda 1 plus lambda 2. So, it is outside this, e to the power of minus lambda 1 plus lambda 2, and then it is lambda 1 to the r, lambda 2 to the power z minus r, and also it is r factorial, z minus r factorial. Now, if you see that r plus z minus r is z, so I just want to divide by z factorial, and I multiply by z factorial in this summation 0 to z, this is z factorial by r factorial, z minus r factorial, then lambda 1 to the power r and lambda 2 to the power z minus r. So, this has some kind of special form. So, we know that this binomial expansion we discussed earlier, a plus b whole to the power some m. So, this is nothing but some k is equal to 0 to m, m c k, a to the power k, a to the power of k, and b to the power of m minus k. This is the binomial expansion we already discussed earlier. So, in this in the previous things, you can see that probability of z is equal to z, probability of z is equal to small z. What we are finding? We found this e to the power of minus lambda 1 plus lambda 2 by small z factorial. Then this summation r is equal to 0 to small z, r is equal to 0 to small z. So, 0 to small z, these things it can be written as z factorial by r, zcr. So, zcr, then lambda 1 to the power r, lambda 1 to the power r, and lambda 2 to the power z minus r. So, this is, you can see that z minus r. So, then if you can compare this with this, so this is e to the power minus lambda 1 plus lambda 2 by z factorial, and this is nothing but if you compare with this, this is lambda 1 plus lambda 2, because a is lambda 1, b is lambda 2. If you compare, then lambda 1 plus lambda 2 to the power z. So, this probability mass function of z pzz, it is given by, this is probability that z is equal to z. This is nothing but we can write e to the power of minus lambda 1 plus lambda 2, lambda 1 plus lambda 2 whole to the power z by z factorial, whenever z is nothing but 0, 1, 2 like this, and this is equal to 0, otherwise. See that it has some similar form, probability mass function of the Poisson distribution with parameter. So hence z is equal to x plus y has a Poisson distribution with parameter lambda 1 plus lambda 2. So if any problem, it is numerical problem, it is given that suppose independent Poisson random variable are there related to that, so then you can use this concept. So here let us see some problem. Let us consider this numerical problem. Suppose that a number of telephone calls, suppose that the number of telephone calls coming into a telephone exchange between 10 AM and 11 AM, 11 AM, say x1 is a random variable with Poisson distribution, random variable with Poisson distribution with parameter 2. So here actually what we discussed, lambda 1, this is nothing but Poisson distribution with parameter 2. Similarly, the number of calls arriving between 11 AM and 12 noon, say x2 has a Poisson distribution with parameter with parameter 6. So, lambda 2 equal to 6 here, 6. If x1 and x2 are independent, what is the probability that more than 5 calls come in between 10 AM and 12 noon, in between 10 AM and 12 noon. Okay. So, let us go through this problem again. Suppose that the number of telephone calls coming into telephone exchange between 10 to 11. So, basically if you consider this time like this 0, 1 like this, suppose this is 10, 11, 12. Okay. So, between 10 to 11 it is random variable x1, number of telephone coming between 10 to 11, Poisson distribution with parameter lambda 1, and lambda 1 is given 2, and in this range between 11 and 12, this is Poisson distribution with parameter lambda 2, lambda 2 equal to 6. This is Poisson distribution, x2 has Poisson distribution with parameter lambda 2. So, here lambda 2 is equal to 2, it is given with the parameter lambda 1, lambda 2. If x1 and x2 are independent, so independent it is required, because you can see that before we found that z is equal to x plus y. So, here what is it is asked, if x1 and x2 are independent, what is the probability that more than 5 calls come in between 10 n and 12 m. So, if you want to find the number of telephone calls between 10 and 12 noon, so that means it is the total number of calls x1 plus x2. So, that means we have to consider this random variable z. We know that x1 plus x2, because they are independent, it has Poisson distribution with parameter lambda 1 plus lambda 2. So, this lambda is equal to lambda 1 plus lambda 2, what is that? Now, we know that lambda 1 is equal to 2 plus lambda 2 is equal to 6. So, this is nothing but 8. So, this Poisson distribution, now we know that z has Poisson distribution with parameter 6. So, 6 plus 2 8, sorry, lambda 1 plus lambda 2, it is lambda 2 is 6, 6 plus 2 8. So, Poisson distribution. So, probability that z is equal to z we know now, it is nothing but e to the power of minus lambda lambda to the power z by z factorial whenever z is equal to 0, 1, 2 and it is equal to 0 otherwise. What is lambda here? Lambda here equal to 8. So, then it is known now, we can ask any probability now. So, this probability is that, what is the probability that more than 5 call comes in between 10 and 12 noon. More than 5 call, how we will find? This is probability that z less than equal to 5. So, more than, no, it is asked probability more than 5. So, it is more than 5 means let is strictly greater than 5. So, that is nothing but strictly greater than 5. So, which is nothing but 1 minus complement or that z less than equal to 5. So, how we will find that? This is how we can find probability that z less than equal to 5. This is nothing but summation of z small z is equal to 0 to 5 e to the power of minus lambda is here 8. So, 8 to the power of z small z by z factorial. So, this is nothing but this. So, this is e to the power of minus 8. So, then you have to numerically you have to 8 to the power 0 is 1 plus this is 8 plus 8 square by 2 factorial plus 8 cube by 3 factorial plus 8 to the power 4 by 4 factorial plus 8 to the power 5 by 5 factorial. So, then you have to find this sum. So, then e to the power minus 8 into this. So, this sum you have to numerically you have to solve it. So, this value actually nothing but you can check that you can use calculator. This value is nothing but 0.8. So, this 0.1912. So, this is 1912. So, this is this value. So, now probability that z greater than 5, this is the question. This is 1 minus probability that z less than equal to 5. This is 1 minus z less than equal to 5 is 0.1912. So, this is you can simplify these things, this is coming 0.8088. So, this is the one use of this concept, the sum of these Poisson random variable. So, let us I hope you have understood these things. So, now we will just do another problem on Poisson distributions. Let us discuss this. So, suppose it is asked that x and y independent Poisson random variable. So, suppose let x and y be independent Poisson random variable with parameter lambda 1 and lambda 2 respectively. Suppose it is asked that find probability that x is equal to y. So, how we can find that? So, like we could find the joint distribution, like y probability of z is equal to probability mass function of z, where z is equal to x plus y. But here it is asked what is the probability of x is equal to y, because they are independent. So, let us find out that using this independence we can use this. So, now what will be the probability? Probability of x is equal to y. So, that means this is nothing but the how x is equal to y. So, x and y, if it is taking some value r, then it is also has to be taking r. So, this is nothing but summation that r is equal to 0 to infinity probability that x is equal to r, comma y is equal to r, because it is also comma means intersection, both has to be same, that is the probability that x is equal to y. So, then we can find out this value. So, now because they are independently distributed random variable, this is nothing but the intersection, this is nothing but summation r is equal to 0 to infinity probability that x is equal to r into probability that y is equal to r. So, now we know that because they are this is Poisson random variable. So, we have several times we have written the probability mass function. So, it is nothing but e to the power of minus lambda 1 to the power r by r factorial, e to the power of minus lambda 2 to the power r by r factorial. So, this is the, so now this is nothing but e to the power of minus lambda 1 plus lambda 2 summation r is equal to 0 to infinity lambda 1 lambda 2 whole to the power r by r factorial square, because it is r factorial into r factorial square it is coming. So, lambda 1 lambda 2 whole to the power r by r factorial square. So, now this is we cannot simplify this, we do not have any other, but it will be a convergent series that we can say, because see that this is less than equal to basically 1, it will be, you can see that. So, now from, because it will be less than equal to if you take one of the value, because it is multiplying with the some probability which is less than 1. So, that is why if you multiply because it is less than equal to sum of r equal to 0 to infinity one of the value probability of x equal to r. So, this is actually less than equal to 1. So, that is why it will be convergent, but the value of the convergence, what is the value we will get, that we cannot find that, we have to keep as it is. So, this is the final answer here. So, this is the answer of this problem. So, hopefully you are following that we have completed Bernoulli distribution, binomial distribution, some of the there how we can compute their mean and variances, and Poisson distribution, how we can compute their mean and variances, their probability mass function, cumulative distribution, the function, and their graphical representations, and also some of the numerical problems also we have already solved. So, hope you have understood or you are following. So, next we will discuss some other distribution. So, some continuous random variable we will discuss. So, like we will start with some uniform distribution. Now, we will discuss some of the important continuous distribution, continuous random variable. One of the random variable, it is known as uniform distribution. So, uniform distribution is defined on a interval. A random variable x is called a uniform random variable over a and b are two real number, where a is less than b if it is its probability density function is given by f of x is equal to 1 minus 1 by b minus a whenever a is less than x less than b. So, now you can, here we can see, because it is a uniform distribution. So, in a real line, suppose it is a and this is b, any two number a is less than b, any two real number, because it is uniform distribution. So, uniform distribution means it is not, it is like discrete case we say all point having same probability, but here because it is density, it is a constant density. So, here actually, so this is constant two number. So, this is nothing but some c. So, this f x of x, this is constant over the region x is greater than a less than b, because it is a continuous random variable, you can write half open half closed or closed interval also. This is 0 otherwise. Now, what is the values of this constant? Because it is a probability density function, it will satisfy all the properties of the probability density function. So, because it is a you know that you have already discussed, it is greater than or equal to 0, that is why C has to be greater than 0, otherwise it will be otherwise it is 0. So, that is why, and also this if you take the integration over minus infinity to plus infinity f x x dx, this should be is equal to 1, and it is actually 0 outside this interval, which implies a to b f x x dx, this should be is equal to 1, which implies because f x x dx in this interval is nothing but a to b, this is nothing but the constant dx, this is equal to 1, which implies c into b minus a, this is equal to 1, which implies c is equal to 1 by b minus a. That is why this is a uniform distribution, c has to be 1 by b minus a. So, this is nothing but 1 by b minus a. So, a random variable x is said to have continuous uniform distribution over, we say some AV, if the probability density function of x is given by probability density function of x is given by f of x is equal to 1 by b minus a whenever x is greater than a less than b, this is equal to 0 otherwise. So, this is the now this should be the probability density function, suppose this is y axis and a and b any real number. So, this is the probability density function, this should be the graph of the probability density function. Now, suppose we want to find the cumulative distribution function of this random variable. So, how we can find the cumulative distribution function?